Hello, hello, can you hear me? Hello. Mm.
السلام عليكم. دكتور حسام مشرف. دكتور روثانا السلمي. And maybe with her colleague Sarah الحجيلي. Sarah already there. And we have Ahmed الحازمي. دكتور أحمد الحازمي. And دكتور أحمد حلواني. You are here. It's okay. السلام عليكم. No answer. Other colleague. You can hear me? I think. السلام عليكم.
Yes, we can.
سامع.
Thank you.
You can hear me? It's okay?
Yes, sir. Yes, thank you.
Okay, thank you. حسام مشرف، أروى الشنبري، شهد الطلحي، تماهر الشريف. This is the first speaker. Using machine learning techniques to moderate CO2 emission in PSA. Second speaker, smart visual pollution. روثانا السلمي. No answer. السلام عليكم. حسام مشرف. حسام مشرف. حسام. دكتور حسام. دول الموجودين معه. صار بس دول other person. طيب. Your paper جاهزة يا دكتور أحمد؟ Your presentation here. Check the connection. It's working. Where is from there?
Hello, can you hear us?
Yes, we can.
Yeah, you can hear me, right?
Yes, very well.
Okay.
حسام مشرف. دكتور حسام مشرف. دكتور حسام. No answer. You are حسام.
Which presentation, doctor, you have it? Which one? Which one? The tower theorem? Using this one, right? Third, no, the first. Third one. Third one. Nothing between. Yes. From this side.
Okay. Right. Shabab, other colleague there, you can see the slide? You can see the presentation? It's
Yes,
working?
thank you. Yes.
Okay, go ahead.
So happy to be here. Yeah.
You have a mic?
You have to use it, please.
Now we can't hear you.
Thank you, Dr. Hassam. And we receive any comments from outside colleague. If you have any question, go ahead, please. Use your mic. Dr. Ahmed. Do you need? Yes.
That as you have done the research on this, so what do you think? You have the research about this carbon dioxide emission reduction idea. So what do you think? What is the adoption rate of using these hybrid cars or all that? Yeah, all over the world or specifically here in Saudi Arabia?
And I'm sure that some people are working on that. There are open data for many things, but particularly for this one, other researchers in the literature review work on Saudi data, but it is not related to the vehicles that I showed you, to the vehicle characteristics, like number of cylinders. Just this year, we had this measure as a total, but it's not enough. I have to rate it with some. But definitely it could be collected like that, by the way, if they insist. Yes, that's very important.
Okay. No more questions. Dr. Hussam, can you look at about the data set you have, the size of the data set, the format of the data set, and this data set can be used using machine learning. It's okay, we agree. Yes. What is about the size? This is a parameter. This is a parameter. What do you mean by sample? It's a record?
The record.
What is about the length of the record? It's the maximum. It's a byte. The size, the total byte of the data set.
Right now, but if you see just show display, he will show each.
It's a text format.
This is the integer, this is a float, this is cut, and he will put the size.
CSV format? CSV.
Yes. So this.
Okay. Finally, within your future work, can we use this scenario to answer, to create a model that which vehicle car is, it's include something of high emission vehicle or low emission to answer the question?
Having these results that I showed you,
Yes.
we added an explanation level of interpretation because it's during the building of the model, and we came out with these sort of rules like if
This is a searching to answer the question. Yes. Less than or equal. Yes.
data, if
Yeah, it's okay.
greater than this, then you would not do it. So we have certain rules. When you apply this rule answering a question, use the data, and bring out the type of cars that you need.
Why you mention about only with KSA? Your model is working with Saudi Arabia or we can,
Canadian data, but because we don't have it here, but the same cars are the same. It's just the distribution is different. The distribution of the cars is
yes.
I think Chevy and GM, the same thing happening here. That's BM. I don't know about BM.
What is the BM?
BMW is that-
It's include huge emotion, huge. What is the indicator here at this level? This is a number for what? Sample, yes. The distribution of the data. Okay.
Because Chevy, GMC, Ford, and Dodge.
Yes.
Close.
Okay.
Same, almost the same.
Thank you, Prof. Hussam, about your great work.
Thank you.
Next speaker.
Just so that you know, we can't hear the speaker's microphone out here.
Yes, go ahead.
Hello, assalamu alaikum.
Wa alaikum salam.
I think it's my time to present our paper, Small Visual Pollution Detection System.
Dr. Uthana or Sarah?
Sarah, Dr. Sarah.
Yes, yes. Go ahead, Sarah.
Yeah,
Yes.
just allow me just to share my screen.
Yes, you can share your presentation, Sarah.
Just a second.
Smart Visual Pollution Detection System. Yes. Share your screen.
I don't, it's not. Just a second.
سارة أنت شايفة الشاشة؟
أيوة بس مو راضي يعمل just a second. أيوة خلاص. دقيقة بس. Is the screenshot, is my screen clear? Can you see it?
Yes, we can. Thank you.
Okay. Okay, first of all, thank you so much for having us. I'm here to present our student graduation project. We worked on creating a smart system to detect visual pollution, things like graffiti and any sort of trash system that is around urban cities. The reason I will start first just to give like a few small introduction about the effect of visual pollution. So visual pollution generally just affect the environment, the quality of the environment, the quality of lives, and specifically when we talk about rapidly growing cities like we have here in Saudi, all these kind of like pollution, they kind of like decrease the quality of life and just generally are not a good, does not have a good effect on the environment. It will give the authorities more work in cleaning it, recycling it, and etc. So to address this and to help the authorities to make our environments more less pollution, let's say, we decided to use the technology that we have from IoT to help detect and identify the location that has this kind of pollutions and give notifications to the authorities to help mitigate the effects immediately. So in small Same. So our problem basically was that we wanted to get rid of the visual pollution as much as we can. And the challenge was that the current state of the system that exists, they are not very smart in a sense that they lack any live monitoring system which help detect this pollution immediately and notify the authorities. And our objective was to create a cost-effective system that utilize the IoT technology and the established network in the country to help visual detect and monitor the visual pollutions. So our objectives were to create a system that helped detect visual pollution in real time. We wanted to use the technology of IoT, and we wanted to use machine learning. Specifically, we wanted to use computer vision techniques to help us detect these the pollution. We also wanted to provide data visualization to help the authorities to deal with all these notifications and act accordingly to help mitigate it, and also they may also assist authorities in general to help managing and mitigating these the pollution in the area. So as you can see here, we have a picture of our system architecture. The idea is that our device has a camera sensor, which captures frame all the time. Once the frames are captured, they will come to the Raspberry Pi, and the Raspberry Pi will do the image processing with the machine learning algorithm that is trained on a data set of 400 images data set. And the result of this training, if the device finds like a visual pollution, then it will send a notification to the dashboard, and the dashboard is basically run by the authorities, and then the authorities will able to look at it. Will send the visual pollution picture, also the location of that pollution, and so the authorities now have the full information they need to send someone to take care of this. In the previous work, so we did a literature review on the previous work that was done on similar systems. Generally, as you can see here in this table, so we looked for object detection models in general. We looked at this kind of metrics. So we looked at the type of waste detected. We looked at devices used. Did they alert or they didn't alert? And did they have a dashboard, or are they human-based or not? So as you can see, the type of objects kind of like varies between 3 up to 18 types. Our system actually currently can detect 5 types. The device used, generally they are using mobile phones. But however, our device kind of distinguishes that it uses Raspberry Pi. Again, while all the previous works that use mobile, they also do alert. However, none of them have a dashboard where you can go access and see the photos, see the images of the pollution, the locations, and all the data related in capturing and detecting that kind of pollution. They also, the mobile-based ones are basically, they are human-based, while our system, as you can see, is not human-based, so it's kind of like it's automatic. We set up the device will be able to monitor the area, detect the pollution, and then send notification of the detected object. And comparing to other studies that we have read, so the yellow-based system achieved 80% accuracy for visual pollution detection in DECA. But again, as we mentioned, they didn't mention any device, and it doesn't use dashboard, and it only has 6 types. We also have the system efficient DET, which achieved 93% validation accuracy with the 3 visual pollution classes. Also, we have the Menthar app, which help user report visual. So it's not based on machine learning. It's basically, it just allows you download it and allow user to capture the image of the visual pollution, and then just inform the authority of the pollution, asking them to mitigate it. So the key insight here, what we kind of came out with is that the main things that all these systems lack is basically real-time monitoring and the speed in which they detect the pollution objects. So after building the prototype, as you can see, so our system was able to detect plastic cans, detect this tissue paper, and detect it with a high accuracy. This is specifically, we have the results here. So in terms of like the average accuracy, so we have like for the cup detection, we have 77.7% accuracy. For the bottles, 83.3%, and for the paper is 70.9%, which is a decent kind of results. How this compares with other system? Basically, it was faster. It was detecting the object faster than the other system, while also be able to detecting the object while also monitoring the environment and alerting and sending alert to the dashboard simultaneously. So this was like a mini graduation project for our student. They were able to develop the prototype. They had the device, and it works as it is as a prototype. It works very well. What we want to do in the future is basically is incorporate more real-time analytic for protective methods, able to predict what kind of area that needs more maintenance in the future. Also include this in more autonomous cleaning reports and improving the detection accuracy with having larger data sets. We were very short in time. We only had a data set that is 400 images set size. So we would like to work on larger data sets. Also, it will be nice to see how we can incorporate drones into the project and see how that does for monitoring and detecting, and how faster this could be. In conclusion, so this project offers a great solution to address the visual pollution, incorporating both the IoT and the computer vision. It's very cost effective, it's scalable, and the main characteristic is that it supports real-time monitoring and alerts. It helps authorities maintain and clean and mitigate all the kind of damages that are done to the environment more efficiently. And it's also very flexible, that we can establish it in many or in various locations throughout the cities. Thank you. So
thank you, Dr. Sarah, about your presentation. Do you have any question, Dr. Ahmed? Go ahead.
My first question is, you didn't define for us the visual pollution. And also, you said your system detect 5 types. Which types of visual pollution your system detect?
So what we mean with visual pollution, we basically means that anything that's kind of in terms like of trash.
Yeah.
Then, you know, like trash, anything like graffiti writing on the walls, anything that visually kind of like, let's say, pollute the environment, like in terms, you know, where like any trash, like any debris, trash, graffitis, anything that's kind of like pollute or, like say, damage it's more like it's how do you say it? It's more like it's not visually appealing for say, let's say, in the city. As for the 5 items, we were able to do a cup, which is a paper cup, and a plastic cup. We did bottles, as you have seen in the picture, and also we did paper. So we did a lot of type of specifically, it was a metal bottle and papers.
Okay, thank you, Sarah. Just came late, but I heard that you say a scalable system. What do you mean by the scalability of your system, and how you measure that your system is scalable or not?
Well, it's scalable because it's in terms like it's very cost effective. So it's not does not cost very much, and because it's at the current state, like you can only just have it could cover like a bigger area. So it could have a large area. So it will be scalable in terms that it will be able to cover the whole, let's say the whole city, and it also because it relies mainly on so it's like I said, it's scalable because it's more cost effective.
Yes, scalability has something else. Scalability means that you will present the service by the same.
Yeah, I mean, yeah, as a service, because eventually when you scale, like if you're able to cover the whole city, then like the dashboard will be able to also to give you access to all locations in the city, and all the data will be sent to one place, meaning that and that system could actually so the software part is basically it's going to be the same. The only thing that you need to scale is or let's say scale is the hardware. So in that term, even adding more hardware, it will not affect the original system.
Scalability, do you mean by the scalability is the software which you have made, or the scalability of the hardware system, vehicles, and something like that? I don't know what do you mean by scalability in your paper here.
Well, scalability meaning that it will cover larger. I mean that the system will be able to cover larger area. So I mean, what we did, we started with a very small aerial building, and what we mean is that it will be able to cover cities. It will be able to cover like the whole country. It's more like the coverage area.
Okay, thank you, Sarah.
Thank you.
We have, you didn't mention about the limitation you have.
Well, like we said, because like we had a very short amount of time, so our data set is not. We would have loved to be able to work on a larger.
Yes.
data set.
Other thing, this is the scalability issue also. What is else?
I think we will be able to like we'll be able to make the prototype. We'll add things like
Okay.
we incorporate some drones, and also at the moment, like the device it works at the moment, it will be it just works indoors. So when we tested it, only worked indoors in our college building. So it will be a great thing to be able to make sure that it works outdoors as well.
Okay, thank you, Sarah. Good work, inshallah. Next speaker related to Ahmed Al-Harthi. Dr. Ahmed Al-Harthi.
Yeah, I'm here. It's actually Ahmed Al-Hazmi.
Al-Hazmi, yes.
Okay, so I'll share my screen right
Go
now.
ahead.
Okay.
Yes. You can share your screen, Ahmed.
Okay, I'll be sharing my screen now.
Yes.
So it says that I need to join the meeting for the share to be effective. So just give me 1 second, please. So do you guys hear me right now?
Yes, yes, go
Okay.
ahead.
All right, so I'll share
You
my
didn't
screen.
share your screen, please.
Do you guys see the presentation? Is it clear?
Not yet. Not yet.
I can see it.
Do you guys see the screen? It shows me that the sharing is effective and you should be able to see it.
I can see it.
Yes. It's okay. No, another, yes, privacy, yes.
All right. Good afternoon, everyone.
Privacy.
Yeah, thank you for having me today. I'll be talking about our paper, which is about privacy in smart digital healthcare during Hajj and
Dr. Ahmed,
Umrah.
we
Chad,
still can't, we
Ahmed,
still
wait.
can't see.
Ahmed, wait, please.
We still can't
Uh,
presentation.
okay, okay.
What is the problem, Dr. Ahmed? No. Yes, فين الناس؟
Dr. Ahmed, can you stop sharing and do the sharing again?
All right, I'll do that.
Okay.
So I just did that. I just shared the screen again. Do you guys see the presentation?
No, we can't. Jeff, can you see the presentation?
Yes, I can.
Okay.
I can see it, yes.
I'm not sure why we can't see it. Okay.
روح على الشير الثاني روح على الشير الثاني دي. شوف كده. كليك عليها. Multiple, it's okay.
Maybe look at your Zoom view options.
Hello, Mr. Ahmed. Can you
Yeah,
share
hello.
now?
I'm sharing my screen. Should I stop sharing and share it again?
Yeah. Try again.
Okay.
It's working. Go ahead, Ahmed.
Okay, go ahead.
All right. So thank you everyone for having me today. I'll be talking about our paper, which is about privacy in smart digital healthcare during Hajj and Umrah, challenges and recommendations. So this is the outline of this presentation. I'll be going over multiple sections of the paper. I'll start by going over the introduction, then motivation, then I'll be talking about the ongoing privacy challenges in smart digital healthcare. After that, I'll be going over the analysis on the Sahati app, and then I'll talk about the recommendations that we made in the paper. Makkah is a smart city. It's actually one of the 5 smart cities in Saudi Arabia, according to the Institute for Management Development. And one of the main services in Makkah is a smart digital healthcare, which is an essential service deployed to ensure smooth experiences for all individuals performing Hajj and Umrah. It actually helps with faster identification of people needing urgent medical intervention. It helps with the accurate medical diagnosis and continuous patient health monitoring. One of the main components in smart digital healthcare is the data that we collect from patients. So it's actually a major component needed to preserve the sustainability of delivering healthcare services, and protecting this data is essential to encourage users to consent to the collection and exchange of their data. The cost of data breaches for healthcare is actually the highest among all other sectors. Actually, in a new report in 2023, it was observed that there are continuous increase in the cost of data breaches in the healthcare industry for the 13th consecutive year. So in our paper, we explored the ongoing privacy challenges that may hinder the sustainable delivery of smart digital healthcare services to individuals performing Hajj and Umrah. We analyzed the iOS version of the Sahati app, which is the official healthcare platform in Saudi Arabia, to evaluate its ability to address these challenges. And then we made recommendations based on our analysis to address the presented challenges in the paper. So the motivation behind this paper was actually, we know that Saudi has the Vision 2030, which has multiple programs that were established to meet the goals of this vision. One of these programs is the Pilgrims Experience program, which aims to increase the opportunities for a more significant number of Muslims around the globe to perform Hajj and Umrah. One of the indirect goals of this program is to facilitate the delivery of healthcare services and improve the value of these services to individuals coming to the kingdom. Another program is the Healthcare Sector Transformation Program, which aims to provide accessible healthcare services and equip the kingdom with healthcare facilities that employ the latest medical materials and tools. Also in Saudi, we have the Personal Data Protection Law, which identifies the health-related data as a sensitive data and actually specifies how this data should be processed to ensure that the privacy of the data owners is preserved. So the interconnection of these programs and their objectives motivates our work to focus on the privacy challenges in smart digital healthcare during Hajj and Umrah. These are the challenges that we examined and presented in the paper. And in this presentation, I'll be talking about 2 of those challenges: the data collection, processing, and storage, and privacy preferences. So when it comes to the data collection, processing, and storage, patient data actually goes through multiple phases. In the collection phase, data is collected digitally via an app, a smartwatch, a smart heart monitoring, and other similar devices. In terms of the processing, it can be performed locally on the owner's device or on the cloud of the service provider. And when it comes to the data storage, the goal is to store this data reliably and securely. So in terms of the challenges, we have multiple challenges, such as devices that can collect more data than needed to function properly. Also, another challenge is ensuring only accurate and trustworthy data is stored. The other challenge is determining a reasonable retention time for the stored data. And another challenge is the efficient obtainment of users' consent, especially during the Hajj period. As we know, millions of users come to the kingdom in a short period of time. The other challenge is the privacy preferences. A challenge, as we know that users have different preferences when they're using different digital platforms and applications, and therefore we need to provide means and ways for those individuals to specify their preferences regarding how their data can be captured, processed, and shared to meet the goals of privacy regulations such as the PDPL. And regarding Hajj and Umrah, capturing the privacy preferences of millions of individuals visiting the kingdom from different parts of the world is challenging due to how societies and cultures have different privacy expectations and norms. So in our paper, we analyzed Sahati, as I mentioned earlier, is the official platform in Saudi Arabia. It's an official healthcare platform. Through this platform, you can perform several medical services, such as booking appointments to take the required Hajj vaccination. We analyze the app from different aspects. We analyze the privacy policy, the privacy settings, and users' reviews on the app. So when it comes to the policy, the privacy policy in the app, in the policy, it says that Sahati will comply with all regulations that are PDPL enforced that are related to collecting and processing users' data. When it comes to the user consents, it states that the consent of the users will be captured, especially when the data is obtained from third-party organization. When it comes to the data retention in the policy, it says that the collected personal data of users will be returned and retained until the purpose of the collection is fulfilled. However, personal data may not be deleted if there is a legal requirement that requires the data to not be deleted. In terms of the anonymization of the data, identifiable collected data can be anonymized to allow for the development of the services of the platform, the Sahati platform. Regarding the data access, in the policy, it states that all practices will be followed to ensure the protection of users' data against unauthorized data access, modification, and deletion. In terms of the privacy setting of the app, actually the privacy setting of the app is limited. It actually only offers users the option to turn on or off the Face ID or fingerprint ID features on their phones to expedite the login process. And when it comes to the user reviews on the app, we analyzed the reviews given to the iOS version of the app. We collected more than 600 users' reviews, and we made a word cloud of the 50 most frequented words mentioned in the reviews. And as we can see, most of these words are related to the functionality of the app, such as having the ability to book appointments using the app and the platform. Our analysis showed that there was only one review that mentioned privacy, in which the user says lack of privacy without voicing any complaints or explaining their privacy concerns. So based on our analysis, we made the following recommendations to address the challenges that were presented in the paper. And I'll be going over two of those recommendations in this presentation. So the first recommendation is using privacy audit. It actually helps organizations to have a full review of their policies and evaluate the privacy controls that they implemented. During privacy audit, the auditor can have a checklist that guides him through this process to cover all points and ensure no issues are overlooked. Actually, through the audits, You can also discover any gaps between the required privacy controls and the implemented controls. And by using this privacy audit, we actually can address the privacy challenges mentioned in the papers, as we can, through this process, identify problems with the data collection, processing, and storage phases. We can actually discover any occurrence of unauthorized access that were made to the data. We can evaluate the anonymization methods used. In terms of the privacy preferences, we can ensure that users' privacy preferences were respected by examining the data that were collected by the organization. The other recommendation is to use a granular privacy control. As we know that patients prefer more privacy controls over their health data to express their privacy preferences. Therefore, by providing a granular control over the privacy options in the apps and the platforms, we can address two challenges, such as the privacy preferences challenge and the access control challenge, as users can identify the entities that can access their private data via the implemented privacy settings. And through the granular privacy settings, we can enable users to specify the privacy controls that are suited to their preferences and needs. However, we have to make sure that we don't provide the users with many options that can overwhelm the users and may cause mental burden on them.
Ahmed, take care. Take care about the time, please. Take care about the time.
Okay. So in conclusion, in this paper, as we mentioned, we examined privacy challenges that may affect the delivery of smart digital healthcare. We analyzed the app, and we made recommendations to address these challenges. Thank you for listening.
Ahmed, you have a policy to determine what we need to make your reviews. You have a questionnaire. You prepare a questionnaire and distribute this questionnaire over a group that answer about some to make this one privacy or this one it is not a privacy.
So what we made in terms of the privacy policies, we analyzed the official policy of the Sahati app to make sure that it addresses the challenges that we mentioned in the paper. So we analyzed the points in the privacy policies that are related to the challenges that we mentioned. So a questionnaire can be something that we look into for the future studies to examine how users view the digital platforms and apps that they're using in the kingdom, and to make sure that their privacy preferences and are respected, and they have the options to specify their privacy preferences and needs.
And you are sure this privacy, it's related to Hajj and Umrah only? Or
So-
you can make it in other domains?
Yeah, you can apply it to other domains, but we mentioned the points that are related to Hajj and Umrah specifically. In terms of the privacy preferences option or challenge, we said that the main challenge is to capture these privacy preferences for millions of Muslims that they come to the kingdom in a short period of time. But it can be applicable to other domains as well.
You have a result with your research track? You have a computational values or something like that?
We haven't made a computational values as I said. The only computational values that we analyzed was the reviews on the app to look for any mentions of the privacy options that are related to the app itself.
Okay. Another question from Prof. Muhammad.
Assalamu alaikum, Dr. Ahmed.
Salam, Dr. Muhammad.
Is the same is the all who first of all who determines the privacy and for which information And is all information have the same level of privacy?
Okay, so determining the types of the data and whether the data is private or not. So you have the BDPL regulations, and in that regulations, it specifies that the types of data that are private. So basically, if the data is identifiable, it can identify the individual, then that data can be sensitive, and therefore protecting such data is essential. And then you have the preferences of the users themselves. Some users view some types of data as private, and some view them as not. So by allowing those users to specify their preferences, you make sure that you protect the privacy of that user.
Okay, thanks.
Good work, inshallah.
Thank
The
you. Thank you.
next speaker related to Dr. Ahmed Halawani. Can you share your screen, Dr. Ahmed? Okay. Control all of them, yes.
Can you hear me? Yes, yes. Okay.
Yes, we can.
Okay. طيب اوكي بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. I will present by sitting here, okay? So it's easy for me to move between the slide. So today I will talk about enhancing traffic safety by strategically placing the roadside unit for connected vehicles, especially at intra-city roads. So first, let's start with the alarming stats of road safety. Globally, there is 1.19 million deaths by traffic accidents, which can be, say, as like a death happening every 27 seconds related to traffic accidents. So this is an issue that's globally and need to be investigated. This research focused on connected vehicles and how connected vehicles will enhance road safety and how can we do that. Let's start by talking about the communication in connected vehicles. Connected vehicles has different form of communication like V2V, vehicle to vehicle, or vehicle to infrastructure, or to pedestrian, or to network, and which is okay. They can hear me. Yeah, we confirm with them. Okay. So as I said, there is different form of communication like vehicle to vehicle, vehicle to infrastructure, to pedestrian, to network. And nowadays they call it V2X when they mean vehicle communicating to everything. So connected vehicle communicate different type of messages. And one of these messages is safety and like signal phasing and timing and mapping and travel information and roadside alert. The one we're concerned about is the basic message or basic safety message and how that will collaborate to improving road safety. I will go with some form of connected vehicle and enhancing road safety, like the one with warning the driver of not passing when they in two-way roads. This type of accident are deadly and your car will notify you that you cannot pass. Let's see this short video. How I will get the notifications, like trying to pass. You will get a notification in your car that it's not safe to pass, almost like this. Okay, and another form of connected vehicle enhancing safety, like forward collision, when your car informs you there is an accident in front of you ahead, or when car in front of you alert you that there is an emergency braking ahead of you. And also, could your car alert you there is a car coming from blind spot? All these are great in enhancing safety. And how this communication happening? We'll talk about, see the kind quickly. There is two kinds of communication, V2X and CV2X. V2X, it's related or rely on direct communication, and it's called dedicated short-range communications. When vehicle directly communicate to the other vehicle or to infrastructure. Then there is another form or another technology called CV2X, when your vehicle has the ability to communicate directly with the PC5 interface or can communicate through the network. And this is the architecture of the system showing how the car can communicate directly or through the network. So in a road safety application, connected vehicles rely on direct communication. So we do not rely on communicating. Okay. Can you mute your mic? So it's cannot rely on communicating through the network because of the reliability of the message. So we just rely on direct communication. So when direct communication and road safety and traffic safety, we rely on range of communication. There is different study have done on the communication range, and you can see from these tables, it's going from almost 100 kilometer and down to 125 meters or 425 meters. So there is a range. And if you look at the left side, you can see that it's grouping in the communication community. They communicate, they divide it to the line of sight communication and non-line of sight communication. So we see a huge drop happening in non-line of sight communication. So is that effective for road safety? That's the question. What's the minimum range of communication good for enhancing traffic safety? In highway safety manuals, it says you have to give the driver enough distance for him to take action to stop or to move. It's depend on the reaction of the driver and the speed of the driver. If we look at high-speed road or intra-city road where the speed is 140 kilometers per hour, you see that driver needs 555 meters to make a safe decision, which is not enough in a case of NLOS, because we see the drop in NLOS. So a connected vehicle will be not 100% safe or give a good information in NLOS situation. Okay. So when the communication range fall behind less than the highway safety distance. So LOS and LOS. So what the solutions or what can we do? What we can do is relying on roadside unit to do the direct communication. With a multi-hub communication, the vehicles can send the information to roadside unit. The roadside unit can pass it to other vehicles. So this way you can extend your communication to exceed the highway safety distance. However, you cannot put roadside unit in everywhere because we are talking about intra-city road and highway between cities, so it will cost too much. So you have to find a way to do that. Also, to define NLOS areas, and that's not easy to define it. So what we did is we did a case study for a road between Medina and Yumbo Road. We did first start by having getting the digital elevation model of the study area. There is different digital elevation models, okay? And we use an SRTM 30. I guess it's by US Army or something like that, okay? It has a resolution of 30 meters, spatial resolution, and vertical accuracy of 10 to 16 meters. We take the model of the area, the elevation of the model, we put it in QGIS. We did the fuse shed analysis when you can define the LOS area and LOS area around the point. However, we have a road, so we cannot rely on one point. So what we did, we got the road, we put a point for each 500 meters. Then from each point, we did the fuse shed analysis to define if this point can connect the other point in line of sight, or there is an obstacle between the point and the other point. Well, it's cumulative work, so we did this. The line, we see where is the communication drop, or where is not drop, but NLOS, non-line of sight communication. There is an obstacle, kind of obstacles there. We defined these areas, okay? Then we did some optimizations about installing the roadside units to ensure the communication range exceed the safety distance. So to conclude, this work presents a cost-effective method. It's not a new method, but a cost-effective method where you can define the NLOS using the QGIS or digital elevation models and place the roadside unit on objective of enhancing traffic safety. There is another study that did place the roadside unit for density, for communication range, but here is the focus on enhancing traffic safety from the perspective of traffic engineer. Is this topic important? According to McKinsey, 95% of the vehicles in 2030 globally will be connected vehicles. So we have to do a research thinking about enhancing traffic safety. How can we utilize connected vehicles to enhance the safety? Thank you. And if there is any question.
Thank you, Dr. Ahmed. And we can receive any comments from colleagues.
Doctor, depending on what you make direct communication, it's direct between vehicle and another vehicle, or vehicle through another vehicle?
So the defined direct communication here is, it's direct communication is vehicle to vehicles. Direct message.
But
It's direct.
also you can make ad hoc,
Also-
ad hoc network.
Yes, also. But they're not relying on the network, not relying on the
But
internet.
I'm talking about car-to-car communication
Yes.
until you reach to your destination.
Yes,
So it's far from the network.
Yeah.
I'm talking about network between the car using the road.
yes. So what's the question again?
The question is, for example, if I'm driving my car and if I find the accident in my road, I want to tell the people behind me that there is a car, take care, or something like that. There is any way to use the communication from my car to the car behind me, and the car behind me to the car behind it, and so on, until we reach to the safe distance.
Yes, nowadays, when they start the technology, I don't have the time here. It was like vehicles to vehicle, but now they have multi-hub communication. So your vehicle can't send to the vehicle behind it, but it should be within the range of the communication. So the car will not broadcast the message forever, broadcast it for certain amount of time. But if there is a car behind you at a certain safety distance, or say the communication distance of you, let's say with a line of sight with you 1 kilometer, so this car will receive the message, and this car maybe can produce it to the car behind. Directly to the car
Not
behind.
through the people.
No, directly. If it's within the communication range of the vehicles and within the certain time of the broadcasting, when the broadcasting starts.
Thank you, Doctor.
Any question? Yes.
Assalamu alaikum. Okay, regarding the project ideas, it seems very interesting, but it seems very challenging at the same time. So you have done some maybe or maybe not the feasibility study about this whole project. So again, my question is more likely the adaptability of this sort of idea to the public or to the companies who are developing such sort of vehicles. So this is my first question. Second question is about the networking protocols. Like if maybe you have studied about it. So which protocols you are thinking are suitable for having this sort of navigability between or the control between two different devices for the vehicles. Yeah. So I don't think the protocols for this one. So you are using the already developed standardized
Hello.
protocols for it? Okay, thank you.
So the adaptability of the method, it's rely on open source data. So we just rely on open source data. We have visual or digital elevation models that is open available. If you want to do this work physically, it's going to cost you too much. You want to go to the highway and see where is NLOS areas, but here is rely on open source, and we show a small case study that this is feasible solution. Maybe not what 100% accurate, but it's going to give you enough good result and save you a lot of money and hence yes, it's relying on QGIS. We can in the future work, you can put it with another simulation model for communication network and traffic safety network.
View shield or sheet.
View shield.
This is a simulator or
no? This is just in a QGIS. It's just use the digital elevation models, and you define an observed point and the height of the observed point. In our case, we do it 1.2 meters, like the height of the car. Then you said yes. You then see the line of sight, for example, 500 kilometers around it. We say the receiver, and you give it the receiver height, like 100.2 meters. Then the model will give you the line of sight communication and non-line of sight communication. QGIS software called Q. And I'm using here QGIS. The name of the software is QGIS.
Okay, great work, Dr. Ahmed.
Thank you.
And your work at Jeddah University or where?
طيبة University, Medina.
Yes. Alhamdulillah, ما شاء الله.
I would throw in a comment that to the last question that
Yes,
there's an international.
No problem.
International.
Go ahead.
Oh, I was just going to add in a comment to the last question, which is there's an international standard for CV2X, the cellular vehicle to everything. It's called, it is the international like cell standard agency, 3GPP.
Yes.
Clear?
Thank you. Yeah.
Yes.
Yeah. He just confirming that there's a standardized communication network. Thank you, Dr. Jeff.
If you can write your question again, please, for the message, and we will communicate with you. Go ahead.
Making a comment.
Okay, thank you. And the next speaker related to Mariam Abdelaziz Al-Ghamdi and maybe Dr. Rahma. Yes. Come. Thank you, Dr. Ahmed.
Hello. The primary purpose of using IoT technology in smart home to enhance convenience and flexibility, but IoT have many vulnerabilities to make risk to security and privacy. From this problem, we proposed a model that Zero Trust Network to enhance privacy and security in smart home. Zero Trust Network have a core principle based on never trust always verify، وهذا يعني عدم الوثوق أبدا في أي device or user أو any process in network and always verify. ولكن وإن ظهر يعني بشكل عام أن هذا يشكل بعض المشاكل في الشبكة، إلا أن هذه التقنية لها العديد من الفيتشرز like continuous verification of user and device, last privilege access, microsegmentation, multi-factor authentication, prevents unauthorized access and provides a more focused approach to access control. وهناك بعض الدراسات التي استخدمت الزيرو تراست في الأنظمة التي اقترحتها في أبحاثها العلمية، ولكن كانت تفتقر إلى بعض الأسس التي ينص عليها السكيورتي. فبعض الدراسات تركز على جزء الانتجريتي وتهمل باقي الأسس. الزيرو تراست موديل focus on three security principles like integrity, confidentiality, and privacy. Proposed zero trust model have a scenario simulated environment with device-to-device communication. This simulation in 50 days simulation with 6,000 access attempts daily. Focus on authentication, authorization, and user satisfaction. هذا الموديل يعني كان يقوم بحساب عدد محاولات الدخول اليومية للمستخدمين داخل المنزل الذكي، والتركيز على الauthentication, authorization، وبعض المحاولات اللي تكون unauthorization and unauthentication. إيش تقصد بالتجهيزات الأخرى؟ Yes. Software, device to device. Every device in smart home, it connects together. Device-to-device scenario components consist of three main devices like smart door lock, smart security camera, and smart thermostat. This device connected together and exchange the files and feedback of user and make a process on this file to enhance the user satisfaction. When we implementation the zero trust model, we use some security protocols like elliptic curve cryptography with very strong encryption and low cost, and attribute-based access control to enhance access policies and access control based on attributes of device and user location and network. This algorithm هذه الخوارزمية توضح بشكل أكبر وبتفاصيل أكثر طريقة عمل الليبتك ال ECC وال ABAC بحيث أنه يكون عندنا عدد من المدخلات اللي هو البيانات الديفايس والانكريبشن كيز الببليك كي والبرايفت كي، ويكون عندنا outputs العدد من الماتريكس like false positive rate false negative rate user feedback source attribute based access control and ECC success rate بحيث أنه يتم تجهيز الجهاز وتجهيز المفاتيح ووضع الأجهزة تحت المراقبة. يتم التحقق بشكل متكرر للأجهزة authentication and authorization وتنفيذ ال attribute based access control بحيث أنه إذا كانت ال authentication and authorization success enable secure data exchange يتم السماح بتبادل البيانات وتبادل وتشفير البيانات بواسطة ال K public and decrypt by using K private and evaluate access control in real time. Else, if not success authorization or authentication, block this attempt and put in list of blocked authenticate attempt and monitor device behavior. This device it's make an blocked attempt put under monitor and collect user feedback. In another way, we can see initial ECC and the exchange case check ABC. If it's good, grant access and transfer data and evaluate matrix. Another deny access and put this attempt in blocked authenticate attempt. Evaluation matrix we use in this model to total access count, all access count in smart home, count in this evaluation matrix, authenticate user count, just authenticate user count success count here, blocked authenticate attempt, and false positive rate, false negative rate to calculate the based on false positive rate and false negative rate, we calculate the user satisfaction. Attribute-based access control, success rate, ECC success rate, to evaluation. The evaluation of ABAC and ECC, its work in right way. And after we implementation the zero trust model, we get this result, and we will discuss in this first one, total access count, as we say 6,000 in 50 days. Authenticate user count is 3,000. Blocked authenticate attempt is 2,096. And false positive rate and false negative rate كانت بنتائج جدا عالية توضح مدى فعالية النظام المقترح، كانت بنسب بسيطة، بالإضافة إلى ال ABC success rate وال ECC success rate، فكانت توضح لنا مدى فعالية التشفير وتقييم صفات المستخدم داخل الشبكة. هذا النموذج يوفر لنا موديل يمكن أنها تتكيف لتحسين البرايفسي and security in smart home بواسطة التحقق المستمر للأجهزة والمستخدمين نحو العدد من التحديات لنظام الزيرو ترست. Integration of advanced technology like ABAC and ECC make security more efficient. Thank you.
Have you considered just a single source of trust, or in your model did you allow for the possibility of distributed trust?
Okay, again, please.
Yes, in your model, did you have a single source of trust, or did you allow for distributed source of trust in case somebody started cyber attacking your trust source?
It's a single. It's a single. Can you clarify your question, please?
Sure. If you have a single source of trust, in your zero trust model, your devices are constantly checking, right, back to get trust permission. And that can become a bottleneck both from a computational perspective, but also from a system weakness perspective. Someone can start attacking your trust source. As someone who's had my trust source attacked, I was just wondering if you allow for distributed trust then.
You have answer? Okay. Mariam, you are master degree or?
Yes, master.
Master. From any university?
الباحة University. الباحة University.
الباحة University. It's okay. And this is more than the answer for this question is out of the scope of her research. Please, you mentioned Mariam about the algorithm you have.
Yeah.
انت عرضت لنا من شوية.
Yeah.
The algorithm.
Yes.
And you didn't mention about the implementation.
Implementation of what?
Implemented this algorithm using what? Using Python code?
Yes.
Using MATLAB?
Yes.
Using what?
We using Python code.
Python code.
Yes.
And you used some data received.
Yes, we used a synthetic data and use random function to generate a random data because data in smart home is sensitive, so we can take any data and we need to use this as synthetic data to generate random data. Just
It's okay. Then what is the security issue here for the data itself?
security issue data for what?
You mentioned about protecting
Yes.
privacy
Yeah.
and securing.
Yes, because the system of smart home
Yes.
in this real time in this
Therefore,
time.
After you implement it,
Yes.
your code using Python, you generate something model.
Yes.
To put this model into the mobile phone.
Yes.
Or into the device phone.
Yes.
يعني انت بعد ما انشأتي التريننج موديل.
Yes.
طلعت موديل. We need to apply it as a real application, as a real service. عايزين نستخدمه في الحياة التقليدية. وأنا داخل البيت. Therefore, I wanted to use this model into my mobile phone.
Yes, as application.
This is the scenario.
Yeah.
Yes. Again, to our colleague outside, you mentioned about your question. Can you clarify it with this scenario, please? Okay. No more question. The last. Thank you, Mariam. Thank you very much. We're going to finalize this. We have the last one. هيثم الحمود. هيثم الحمود. Digital twin environment with reinforcement learning. The last speaker. هيثم الحمود. The last colleague, it is not here. هيثم الحمود، أحمد المحمد، غدير الجبرة، أشواق and أحلام العنزي. هيثم الحمود كان موجود؟ هيثم already there؟ هيثم موجود.
Yes, hi, good afternoon, everybody. How are you?
And how are you?
I'm fine. How about you?
I'm really fine. Just my colleague will present our paper.
Yes. Give me 1 minute, please, to show my presentation.
Ahlam, your mic is mute. Can't hear you. Ahlam, you will present, right?
أحلام
أيوة.
العنزي. You are ready or other colleague will be ready? انت اللي جاهزة ولا في اخر يكون جاهز؟
لا أنا إن شاء الله راح أعرض معك غدير الجبارة.
غدير.
أيوة.
طيب غدير يا اوكي. غدير where is غدير؟ اوكي same. اوكي. انتوا اي جامعة يا بنات؟
إحنا تبع أمانة الإحصاء. ده البرزنتيشن واضح من عندكم؟
Not yet.
No, we can't see.
You can see? It's okay. Start.
Share again, Ahlam, now. Okay. Not sure. Can everybody see? Ahlam, we can't see. We lost your presentation.
Now you can see?
Now we can see.
Okay.
It's okay.
Can other colleagues see?
Okay, I start now.
Yes,
1
of
minute.
course.
Let's see the 1 minute.
Hello?
Yes, go
1
ahead.
minute, Ahlam. We can't see you.
Okay.
1 minute. 1 minute. Wait. That's right.
Okay. Hi, everyone. I am Ghadir Ahmed Al-Jubara. First of all, we would like to express our gratitude for the opportunities to present our research paper. We are truly honored to share our finding with all of you today. The title of our study is Digital Twin Environments with the Reinforcement Learning Based on Traffic Control. Traffic cognition is one of the biggest challenges in urban areas. It wastes time, increases pollution, and stresses millions of people daily. Traditional traffic control systems often fail to adapt to real-time condition, leading to inefficiency and delays. This is where digital twins come in. They are virtual replicates of physical systems and that update in real time. When combined with artificial intelligence, they can simulate, predict, and optimize traffic flow like never before. This technology is reinforming how we manage urban mobility. In this research, we focused on specific traffic intersection in Al-Hassa in Saudi Arabia. Our goal was to develop digital twins-based solution to reduce cognition and improve traffic flow. The main objective of our research to explore how digital twins can improve traffic control in smart cities, using a real-world case study in Al-Hassa City in Saudi Arabia. To evaluate the effectiveness of inverted pyramid and snowballing methodologies in traffic data analysis, and then to propose digital twins-based solution for traffic intersection management and measures its impact on congestion reduction. Let's move on background and context of our research. Artificial intelligence is a technology that enables machine to learn from data, make decisions, and automate tasks. In smart cities, AI plays a crucial role in processing a huge amount of data from sensors, cameras, and other sources to improve urban systems like transportation, energy, and public service. As you see here in this pictures, IoT sensors collect also the IoT sensors and Wi-Fi cameras, traffic lights, collect real-time data from vehicles and route, while AI and machine learning analyze this data to predict traffic patterns. Now we'll look at the methodology we used in this research. We used two key methodologies, the inverted pyramid and snowballing approaches. These methods help us organize and expand our research effectively. The inverted pyramid methodology is a structured approach that starts with the most important information first. In our study, these methods help us focus on the most relevant traffic data, speeding up analysis and decision-making. The snowballing methodology involves gradually expanding the research scope by building on existing references. This approach helps us create a comprehensive knowledge base for our research. Now, we'll move on the real practice to develop the traffic intersection management. We'll continue with you, Engineer Ahmed. You can start, Engineer Ahmed, to explain the real practice.
Hi everyone. In this study, we focus on a specific traffic intersection in Lahsa called roundabout of King Abdullah Road with Prince Naif Street. This intersection was experienced severe congestion, especially during peak hour. To analyze the traffic flow, we use turning movement count, as we see in the table, to monitor and count the vehicle passing through the intersection. Data was collected over 1 week. This highlighted the need for more efficient data collected method. As we see the picture for the previous situation of the intersection with the roundabout, then we address congestion. We propose DDI intersection, that means diverging diamond interchange, with two-way traffic signal. This design optimizes traffic flow by allowing vehicle to move more efficient through the intersection and reducing the delay and improve overall traffic management and the level of service. As we see in the next slide, we have the level of service for previous situation as if that mean fail and the traffic condition are not acceptable. So we make this study for improve the level of service. After implement the DDI design, we observe significant improvement. The maximum queue length decrease from 500 meter to just 100 meter, and the traffic flow during peak hour become much smoother. The effectiveness of our proposal solution and reduce congestion and improve traffic flow, improving the traffic flow and the level of service. After implement this design and finish the improvement by October 2023, we get the level of service C, level of service B, with delay time only 13 seconds. This the improved success of our development. Now we have seen the real world impact of our solution. Let's explore some other application of digital twin in traffic management.
Okay, go ahead, continue.
Continue, Qadir.
While digital twins offer a huge potential for improving traffic management, their implementation comes with several challenges. Let's take a look at some of the key issues and how we can address them. It's data integrity and quality. Digital twins rely on data from various sources such as sensors, cameras, and GPS. Ensuring the accuracy, consistency, and reliability of this data is critical to effective traffic management. To address this, use data encryption protocols to secure communication between devices and anomaly detection algorithms to identify and correct data errors in real time. The second challenge is cybersecurity risks. Digital twins are vulnerable to cyber attacks, which can manipulate with data and leads to incorrect decisions, which can lead to traffic disruption. To mitigate this risk, we can use multi-factor authentication and rule-based access control to restrict access. In addition, blockchain technology can ensure data integrity and transparency, making it difficult to attackers to manipulate the system. While challenges like data integration and cybersecurity exist, solutions like encryption, anomaly detection, and blockchain can help us over them. In conclusion, we explored how digital twins and AI transform traffic control in smart cities. We discussed a real-world case study in Hassa City, where a single intersection design, as we shown before in previous slides, significantly reduce congestion. We also examined the challenges of implementation digital twins, such as data integration and cybersecurity, and the proposed solution like encryption and blockchain. It's important to keep investing in digital twins and AI for traffic management. Future research needs to focus on extending this solution to larger urban areas and dealing with the new challenges like cybersecurity and data previous. Together, we can build smarter, more livable cities. Thank you for your attention. I would now be happy to take any question you may have.
Thank you for your presentation. So I have many questions for you. First of all, let's start by the roundabout data.
Can you repeat, please? I can't hear you.
So first of all, you are from which university?
We work on Al Hassa municipality.
Oh, you are bachelor or master or PhD student?
What?
You are master student or bachelor student?
Bachelor student.
Okay, so this is a graduation project?
No. We worked on it this year.
Okay. So in the roundabout, you show turn movement count, right? And you said you collect the data for 24 hours. I
Yes.
guess this data is inter-vehicles data to the roundabout, or you actually have the OD, the origin and destination of the traffic entering the roundabout?
No, this is original data. Yes, you can, Engineer Ahmed, answer.
Okay, Engineer Ahmed, is it data showing the origin and destination of the vehicle entering the roundabout, or just the
Yes. This turning movement, we see each vehicle. Each vehicle collect with camera in each side of the road that enter to the roundabout. Camera with IA technology.
Okay. Also, you evaluate the level of service. How did you get the level of service? Is it analytically or using software, the level of service?
Of course, we use software for that. The level of service based on the time, the delay. Based,
I know. Which software?
Yes.
Which software did you use?
FISM.
FISM.
FISM?
Yes.
Okay, but you didn't show us anything about FISM. Also, you start talking about digital twin. We didn't see anything. like I think in the future when you talk about something, you have to show it to the people, right?
Of course, but we focus on the not deeply on the analysis. Just we take some picture for data for the previous situation, and as you see the congestion of the car of the picture for previous situation, and the smooth and the after we implement, because this not only study this study and analysis, then implement. And this data, the last slide, this picture from the site. After apply this design, DDI design, and we get result better than what we get in the analysis. In the analysis, we have in 2021 get 17 delay, 17-second delay. But after we apply this solution at 2023, and we get only 13-second delay.
Also the
Which
core
means,
of the length.
yes, which means is very good study, and very good data, and we have good analysis to get this result.
Okay, thank you, Shabab. You are a teamwork already there in إحساء. انتوا فريق عمل ولا ايش ال
ايوه
فريق عمل
ايوه
كلكم
yes, a teamwork.
engineering direction or computational direction?
Two direction. في مجموعة من الفريق
both of them.
Yes.
Okay. Then وده project بتابلاي ليه تبع الأمانة or تبع something where يعني المشروع ده أو البيبر الساينتفك بيبر هذه بتبابلش لها عشان تسبورت something
لا
أمال إيش؟
لا هي الورقة هي اجتهاد شخصي، يعني مو عشان لجهة معينة، بس هي الفريق التيم وورك من جهة الأمانة.
طيب رائع. نشكركم على هذا التقديم، وده ريال كيس بروبلم. شكرا لكم، موفقين إن شاء الله.
أجمعين. شكرا لكم أنتم أيضا.
At the end, thank you very much. Today we have 6 speakers. Great work, inshallah. We have another session next time in Monday morning, and also we have in Tuesday. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.